Welcome to the deep dive. Ready to dive into something pretty amazing today?
Always.
We're taking a deep dive into the world of iridium.
Ooh, now that's an element with a story to tell.
You know, it's funny. When iridium first popped up, I thought, iridium? Okay, what's the big deal? But then I started digging into the research, and wow, this element is way more fascinating than it gets credit for.
Oh, absolutely. It's one of those elements that's often overlooked, but has some truly remarkable properties and a fascinating history.
Yeah, and for this deep dive, we've got some great sources lined up, excerpts from the Royal Society of Chemistry, some Wikipedia wisdom, and even a whole article specifically on iridium's applications. So we're going to be uncovering all sorts of hidden gems about iridium.
It's like a treasure hunt for knowledge, and believe me, there's a lot to uncover.
Okay, so first things first, iridium is the second densest natural element.
Right.
Like, seriously dense.
It really is. You know, that density comes from the way its atoms are packed together incredibly tight, much denser than, say, lead.
So if you're holding a chunk of iridium, you're going to feel it.
You definitely would.
It almost makes me think of those descriptions of neutron stars, you know, where a teaspoonful weighs like a mountain.
That's a great analogy. But here's the thing. Despite being so dense, iridium is surprisingly brittle.
Wait, so it's heavy but breaks easily. That seems kind of counterintuitive.
It is. And to add to the challenge, it also has an extremely high melting point, almost 2,500 degrees Celsius.
Wow, that's hot.
Oh, yeah. And another thing, it's incredibly unreactive, almost as much as gold.
Okay, so we've got this super dense, brittle metal that laughs in the face of a blowtorch. Before we get into what it can do, I'm curious about its name. The Royal Society of Chemistry article mentioned that it's named after Iris, the Greek goddess of the rainbow, right?
That's right.
But iridium itself is silvery white.
You're right. Metallic iridium is silvery white. But the name actually comes from the incredible variety of colors that its sols can display. Reds, yellows, greens, blues, you name it. It's a fascinating contrast. The densest metal, named after the most colorful phenomenon in nature.
That's a great piece of trivia. So we've got this super dense, brittle, rainbow-named metal that laughs in the face of heat. Where on earth do we find something this hardcore actually being used?
Well, for starters, something you probably use every day, your car. Have you ever heard of iridium spark plugs?
Vaguely, yeah. They're supposed to be good, but I don't really know why.
Well, they are. And the reason they're so good is because of iridium's incredible resistance to heat and corrosion. Think about what happens inside a car engine. Extreme temperatures, constant pressure, and exposure to all sorts of corrosive chemicals. Iridium can handle it all.
So it's like the ultimate warrior metal, battling those extreme conditions inside our engines.
Exactly. And it's especially favored in high-performance engines like those found in aircraft.
Makes sense. I bet it's used in even more intense applications than that, though, right?
Absolutely. Its high melting point and resistance to corrosion also make it incredibly valuable in other areas where things get really hot, like making crucibles.
Crucibles?
Yeah, they're special containers used to melt other metals. And we're talking temperatures most people can't even fathom, over 2,000 degrees Celsius.
Whoa, over 2,000 degrees Celsius. What on earth are we melting at those temperatures?
Things like super pure crystals for lasers, or incredibly precise components for computer chips. Basically, whenever you need to melt something at an insanely high temperature without the container itself melting or reacting, iridium is the way to go.
So it's not just about raw strength then, it's also about precision and purity. Pretty impressive. But I have to ask, how do we even work with something that's so difficult to melt and shape?
It's definitely not easy. Often, it's used in a powder form and then sintered. Basically, it's heated under high pressure to fuse the particles together without actually melting it completely.
That sounds incredibly complex. It makes me appreciate all the more the technology that relies on iridium.
And there's one more application that might surprise you. Medicine.
Medicine?
Yeah. Specifically, a radioactive isotope of Iridium-192. It's used in cancer treatment.
Wait, this super tough metal is used to fight cancer. How does that even work?
It's a technique called brachytherapy. Tiny seeds of Iridium-192 are placed directly into or near a tumor.
Okay, and what does that do?
Well, Iridium-192 emits gamma rays, which are a type of radiation. These gamma rays target and destroy the cancerous cells while minimizing damage to the surrounding healthy tissue.
Wow, so from powering our engines to helping us fight cancer, iridium really is living up to that superhero element status. But we mentioned earlier that it's rare, right? How rare are we talking?
Iridium is one of the rarest elements in the Earth's crust, significantly less common than gold.
Ah, so that's why it's so expensive. But if it's so rare in the Earth's crust, where else do we find it?
That's where things get really intriguing. Iridium is actually much more common in meteorites than it is in the Earth's crust.
Hold on. Meteorites have more iridium. What's going on here?
Well, this is where iridium starts to tell us a story about the history of our planet. A story that involves a cataclysmic event and the extinction of the dinosaurs.
Okay, now I'm really hooked. Tell me more about this dinosaur connection.
Imagine you're a scientist studying layers of rock. You come across a thin layer of clay, incredibly rich in iridium. This layer dates back about 66 million years.
Wait, 66 million years ago? Isn't that around the time the dinosaurs disappeared?
Exactly. This layer, called the KPG boundary, is like a giant fingerprint left behind by a massive impact event. And the unusually high concentration of iridium in this layer is a key piece of evidence pointing to what caused that event.
This is blowing my mind. So iridium isn't just a super tough metal. It's a key to understanding one of the biggest mysteries in Earth's history.
You got it. And that's just the beginning of the story.
Incredible. I can't wait to dive deeper into this.
This KPG boundary layer, it's not just in one spot. It's global.
So whatever happened, it happened on a huge scale.
Exactly, something that affected the entire planet.
But how do we know it was an asteroid? Not like, I don't know, massive volcanoes or something. Wouldn't they release iridium too?
That's a good question. Volcanoes DO release some iridium, but the amounts are tiny compared to what's in the KPG boundary. Plus, there's other stuff in that clay layer, like shocked quartz, that forms under intense pressure. And these little glassy droplets called tektites, they're created when rock gets melted and cooled super fast.
Sounds like a cosmic CSI episode.
Right. And then there's the Chicxulub crater off the coast of Mexico. Its size and age match up perfectly with the KPG boundary.
So it really does look like a giant asteroid. Iridium helps solve that mystery. It's crazy that this element can tell us about something that happened millions of years ago.
I know. Think about it. The impact was so powerful, it vaporized the asteroid. Trillions of tons of dust and debris blasted into the atmosphere, iridium included. It spread everywhere, settled, and became that layer we find today.
Hard to imagine something that big. Tough break for the dinos, huh?
Yeah. But it shows how much our planet has changed over time. And speaking of change, iridium is doing a lot in our world today, too. We talked about spark plugs and cancer treatment, but there's a lot more.
Like what?
Well, electrochemistry, for one. Iridium resists corrosion like crazy, so it's perfect for electrodes, like in the chloralkali process.
Yeah.
For making chlorine and caustic soda. Essential chemicals for tons of industries.
So it's in everyday stuff, too.
Yep. And remember how hard it is.
Mm.
That makes it good for things like fountain pen tips, compass bearings, too, especially when it's mixed with osmium.
That's surprising. I thought it was brittle.
It is. But mixed with osmium, it becomes super wear-resistant. Did you know the standard meter bar back in 1889 was made of 90% platinum, 10% iridium?
Wow, seriously. So it helped define the meter.
Exactly. And speaking of defining things, it's even in jewelry, added to platinum to make it tougher. You'll find it in high-end pieces, engagement rings and stuff, where you want it to last.
From defining the meter to being on someone's finger, iridium really gets around.
What about the future, though? Any cool new uses coming up?
Oh, tons. As we learn more about materials, we're finding new ways to use it all the time. Like in catalysis. Speeding up chemical reactions. This could be huge GE for things like cleaner energy, even new medicines.
Iridium for a greener planet. I like the sound of that.
Right. And don't forget electronics. It's got great electrical properties. Could be in the next generation of gadgets, transistor sensors, all that. Smaller, faster, more powerful.
Mind-blowing. One little element with that much impact.
And nanotechnology. Remember those tiny robots? Not as far-fetched as you think. Iridium nanomaterials could revolutionize everything, from medicine to manufacturing.
So many possibilities. It's exciting, but kind of overwhelming too. I know. Iridium is a frontier element, always pushing boundaries. But there's one more application I think you'll love. In space.
Wait, iridium is in space.
Big time. Doing some pretty important jobs too. Remember Iridium-192, the radioactive stuff?
Yeah, for the cancer treatment.
Same principle, but in space it's a power source. In a thing called a radioisotope thermoelectric generator, an RTG.
An RTG? That sounds intense. What is that?
Basically, a nuclear battery. Converts heat from radioactive decay into electricity. And guess what contains that fuel?
Iridium, right.
Ding, 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 it's perfect for it. Handles the heat, doesn't corrode. Those Voyager probes, the ones heading out of the solar system, they use RTGs with iridium to keep that plutonium fuel safe.
Iridium helping us explore the universe? That's awesome. Why not just use solar panels, though?
Solar panels are great closer to the sun, where there's plenty of light. But further out, it gets weaker. RTGs give you reliable power even in deep space.
Makes sense. Anything else we're using iridium for out there?
Oh yeah, X-ray telescopes, like the Chandra X-ray Observatory. Iridium coats the mirrors.
Hold on, we're using iridium to see black holes.
Pretty much. X-rays from those objects are super faint. Regular mirrors would absorb them. But iridium's special. It reflects them, focusing them onto detectors. So we can see those amazing cosmic events.
Wow, iridium's a power source. A&D, it helps us see the universe. Talk about a multi-talented element.
Right, from exploring deep space to powering everyday tech, it makes you wonder, what's next for iridium?
From a giant asteroid impact millions of years ago to helping us explore space today, iridium's journey is pretty mind-blowing. It really shows how elements can connect us to, well, everything.
It really does. And when you think about the future of iridium, it's just bursting with potential. As we understand more about materials, I think we'll find even more incredible ways to use it.
So where are researchers focusing their efforts? What kind of cutting-edge applications are they working on?
One big area is catalysis, speeding up chemical reactions. Iridium is already used in some catalysts, but scientists are trying to make them even more efficient, more selective.
So we could have iridium helping us create cleaner energy, maybe even develop new medicines.
Exactly. And there's electronics too. Iridium has some unique electrical properties that make it really promising for next-gen stuff, like transistors, sensors, all those components. We could have even smaller, faster, and more powerful devices.
It's amazing to think that one element could have such a huge impact on future technology.
Yeah.
What about those nanobots we were talking about? Any progress there?
Nanotechnology is definitely a hot area for iridium research. Those tiny robots might not be science fiction for much longer. Researchers are working on all sorts of iridium nanomaterials, and they could revolutionize so many fields.
It's really exciting and a little bit overwhelming, to be honest. It feels like iridium is about to change the world as we know it.
It is. Iridium, with its unique combination of strength, durability, and versatility, is absolutely poised to play a crucial role in shaping the future.
It's been an incredible deep dive into the world of iridium, from its explosive origins to its potential to drive future innovations. It really highlights how even the most unassuming elements can have incredible secrets and possibilities just waiting to be discovered.
And it shows just how important scientific curiosity and exploration really are. Who knows what other amazing elements are out there just waiting to be understood?
Well, that's all the time we have for today's deep dive into the fascinating world of iridium, but we hope you keep exploring, asking questions, and learning. Maybe you'll be the one to uncover the next groundbreaking application for this incredible element.
Until next time, keep exploring.